Okay, so we're going to do a little bit of factoring here. I think that's the biggest issue with our review. First thing we need to do is change, and I told you guys this in class, we're going to change this 37, we're going to change that into a 35, okay? I'll explain why in a moment. So our first problem is 4x to the fourth minus 35x squared minus 9. Okay, first thing you always do when you're factoring is you look for a greatest common factor. So I look for a greatest common factor of 4, 35, and 9. Even 4 and 9, I know they have no greatest common factors, so I know that I don't need to simplify that. So the next thing I do is I look at my first term and my last term. Okay, because I know that this middle term was split up into two parts, and so I'm trying to find the two parts that my middle term was split up into to factor this. So this is 4x to the fourth. Okay, there were two terms that 35x squared was. So what I know about those two terms is that they multiply to be the same thing as 4 times negative 9. So 4 times negative 9 is negative 36. And I know that they add to be negative 35. And here's the reasoning why it has to be a negative 35 and can't be a negative 37. It's because there are no numbers that multiply to be negative 36 and add to be negative 37. How do you know that? Because this is a negative 36. That means that the two numbers, one had to be positive and the other had to be a negative. So negative times a positive is a negative. So we start thinking about the factors of 36. I know the difference is 35, so we can try things like negative 9 and positive 4. Well, negative 9 plus positive 4 is going to give you negative 5, so that doesn't work. So I think about, okay, so what's really high? The highest factor I can think of for 36 is 36, and that's going to be negative 36 times 1. Negative 36 plus 1 is negative 35, so those are our factors. So you can write this out. So this is 4x to the fourth, okay? And then those two little spaces, actually, you know what I'm going to do? I'm going to actually erase this. The two spaces, you're going to put your two factors in those spaces. And the order in which you put them does not matter. So I'm going to just do like a plus a 1x minus 36x minus 9, okay? So my next step is I just kind of split this up into two different parts. So I look at the first two terms and then I look at the next two terms. And I find the greatest common factor of just the first two terms. So I look at this, the only thing that x to the fourth, and sorry, these should be both x squared. This is 1x squared, 30x squared, 36x squared. Whatever the middle term is, that's going to have the same power, so I apologize for that. So I look at these two first terms, the 4x and the 1x, 4x to the fourth and 1x squared, and I know that they both have two x's in common, so I factor that out. So I'm left with a 4 here. I'm taking out two x's from my first term here, so this is going to be x squared. I'm taking two x's out here, so I'm left with no x's. So the only thing that's left there in the first part is 1. My next two terms, I have a negative 36 and a negative 9. Whenever this third term is negative, you always factor a negative. So I'm going to be factoring out, well, the greatest common factor is negative 9. I'm going to be factoring out a negative 9 from both of these. So that's going to be 4x squared, because negative 9 goes into negative 36 4 times, and then negative 9 goes into negative 9 1 time. Because remember, when you're factoring things out, you're dividing. So one thing that I notice now is that I both have 4x squared plus 1 in each part. So it's going to be 4x squared plus 1. So I divide those out, and what I'm left with is x squared minus 9. Now, that's initially our factored form. There is something that I noticed though, because we did a whole bunch of stuff with special cases, is we have a binomial, which is two terms, and we're looking for plus. So I look at the first term here, and this is a perfect square, this is a perfect square, but this is plus, so I can't factor this term anymore. So 4x squared plus 1 is it. But my second term, when I look at it, I have a perfect square in the first, a perfect square in the second, and it's minus, and so therefore that can actually be factored further. So I'm still going to have my 4x squared plus 1, but my x squared minus 9, well, that's my difference of squares. So when I do my difference of squares, I'm going to have two parentheses. One's going to be minus and one's going to be plus. And I take the square root of my first term, which is x, and I put that there and there, and I take the square root of my last term. Remember, it's always, you're going to always take the square root of the positive, so the square root of positive 9 is positive 3, and so we put our 3 there, and there is our final answer. Okay, looking at number 2, first thing you do with this guy right here is you take out your greatest common factor. So I know that my greatest common factor for these terms is x. So I'm going to set my little x aside here. This is going to be 8x to the fourth plus, or 8x, excuse me, to the third plus 27. Okay, now I'm going to remember, I'm just going to actually set that x down here, and I'm going to actually forget about it for the rest of this problem because it gets a little bit confusing. So that x, I know it's going to be my final answer. I'm just going to put my final answer. So all I'm going to be worrying about is this 8x cubed plus 27. So anytime I have a binomial, which is two terms, a couple things can happen. So first off, I look at those two terms and I see if they're perfect squares. So the first term is not a perfect square, the second term is a perfect square, but what I do notice is that both of these terms are perfect cubes. So that's going to be important. The next thing I see is that it is plus. So I have to think about it because we have a nice little formula, kind of a pattern algorithm that says that if you have a cubed plus b cubed, that always factors to be a plus b, which is the cubed root of what's here and the cubed root of what's here, the cubed root of this and the cubed root of this, and then times a squared minus ab plus b squared. And that's something you just have to memorize. So I look at this, they're both perfect cubes. Before I even start, I take the cubed root of each part. So the cubed root of 8x cubed and the cubed root of 27. The cubed root of 8x cubed is 2x and the cubed root of 27 is 3. So my a value in this case, if we're looking at the formula, is 2 and my b value is equal to 3. So from there I just apply the formula. So my first term, so it's going to be 2x plus 3. Okay, and I'm going to kind of draw this out a little bit. Then it's going to be, the next thing, next part is going to be a trinomial. The first term of my trinomial is my first term squared, so it's going to be 2x squared. I know my last term is going to be my second term squared. Okay, and I know in between here, well, this is plus, so my next, my middle term is going to be minus. It's always the opposite, and this is going to be 2x times 3, and the last part is always going to be plus, and that's a 3 right there if you can't tell. So I just simplify this out. So I have my 2x plus 3, that's my first term. Then the only thing you have to remember is you're squaring the 2 and you're squaring the x. So this is going to be 4x squared minus 6x plus 9. Okay, and that's my final answer right there. I look through. Where do I see it? It looks like D is the correct answer. When we get to SOLs, things that you can remember, you know that they have to be opposites. So that's going to be a big deal. And actually, just knowing that they're opposites takes you to D as your only answer. All right, so let's look at 5 and 6. Same deal for 5. We go through, this is a trinomial, so I don't have to worry about special cases. No greatest common factor. So I'm looking for two numbers. They have to multiply to be A times C. So it's going to be 1 times 12, which is 12. So they have to multiply, and they have to add to be B, which is 7. So we start thinking about those numbers. So two numbers that multiply to be 12. Okay, let's say 12 times 1. Well, that's 13, so that can't be right. Okay, so then I think, all right, 6 times 2. Well, 6 times 2 is 12, but if I add those together, I get 8. So let me think of another one. Okay, 4 times 3 is 12, or 4 times 3 is 12, and 4 plus 3 is 7. So those have to be our numbers. So all we do is we take those two numbers and we split our middle. Our middle term is x squared, so they're both going to be x squared. So I have x to the fourth. I have x to the fourth. There we go. And then we have plus, and then this one right here is also going to be 12. 7x to the fourth, so this is going to be 4x squared. This is 3x squared. And then I just split it up into two problems. I find the greatest common factor of these two, greatest common factor of these two, go from there. Greatest common factor of x to the fourth and 4x squared is x squared. So we have an x squared and a 4 left. Here and here, this is a positive 3x squared, so I factor out a positive 3. That's also going to be x squared plus 4. I notice that both terms have an x squared plus 4, so I factor that out. When I take that out, I'm left with an x squared plus 3, and that's my final answer. Okay, so now we are looking at number 6. So number 6, you notice it's not a trinomial, so we don't have a first and last term anymore. So what we look at is now we talk about our binomial rules. And so first thing I look, because it's easier, is I look and see, are these perfect squares? Well, 64 is a perfect square, but 125 is not. So after I check and see, okay, they're not perfect squares, so are they perfect cubes? You can check it in your calculator, but 64 is a perfect cube. It's 4 times 4 times 4. And 125 is also a perfect cube. So this is going to be that special case difference of cubes. And I'm going to remind you again, if it is a cubed minus b cubed, that's going to be, if you factor it, a minus b times a squared. It's actually going to be plus ab plus b squared. So that's the whole formula. And we'll write that out, but you guys should have that down. Okay, so before I start this problem, first thing I do is I take the cubed root of each part so I know what a and b are. In this case, a is going to be 4x, and b is going to be 5. Okay, so we just following the formula. It is a minus b. Okay, and it's minus because your middle term was minus. And then it's going to be a squared. Okay, and then I know my last term is b squared. And in between, it's always going to be the opposite sign. So this is minus, this is going to be plus a times b. And our last term is always plus b squared. So my final answer is just going to be 4x minus 5 times 16x squared minus 20x plus 25. And that's your final answer. So those aren't so bad. You just have to have the formula down. Hopefully you practice that enough in class. Okay. So 7, 8. Okay, so for the rest of these, just the same practice. Greatest common factor is, so the greatest common factor, there's none. So now I try to split the middle. Okay, and I look, there's 2x and a negative 3, so I know that it's going to have to multiply to be negative 2 times 3, which is negative 6. So it's going to multiply to be negative 6, and it's going to add to be, well, our middle term, there's no coefficient there, it's just plain old x squared. It's going to add to be 1. Okay, so think about the things that multiply to be 6. We have 2, negative 2 times 3. Well, that gives me positive 1. There we go. Okay, so it only took one shot. So this is 2x to the 4th. Both of these terms, when I split this x squared up, when you add it, the exponent, the variable stays the same. So this is going to be plus 3x squared minus 2x squared minus 3. I find the greatest common factor of the first two terms, which is x squared. That's going to be 2x squared plus 3. And my greatest common factor of the next two terms, it's going to be negative. And the only factor that they have in common is 1, so I'm going to factor out a negative 1. Because 1's the only factor. My third term is negative. Anytime it's a negative, we factor out a negative. So negative 1 goes into negative 2, positive 2 times, and negative 1 goes into negative 3, positive times. So here's something that's interesting just to keep in mind, is that if these two terms are not exactly the same, if maybe your signs are switched, it's probably because you did not factor by a negative. So I noticed that both of these, a 2x squared plus 3's, are in both terms, so I'm going to factor that out. So it's going to be 2x squared plus 3. When I factor that out of each part, I'm left with x squared minus 1. One last thing, so I just check around just to make sure. We are dealing with binomials again. Are they perfect squares? Are they perfect cubes? First one, I look at it, that's 2 is not a perfect square or a perfect cube, so I know I'm not going to have to do anything with that. That's going to be fine. This next one, x squared minus 1, well, x squared is a perfect square, 1 is a perfect square, so I know I can factor this further to be the square root of x squared minus the square root of 1 and the square root of the x squared plus the square root of 1. And that's our special case right there. Okay. Number 8, a lot of you're like, oh, that's a perfect square, but not a perfect cube, so on and so forth. Of course, the first thing you always have to do is find the greatest common factor. Greatest common factor of 16x cubed and 2 is 2. So I factor, excuse me, I factor out a 2. So I set it aside. It's going to be 8x cubed. Sorry, another interruption. I started choking a little bit and then lost my place. Okay. So continuing with that, I factor a 2 out, so I know that I'm going to have a 2 factored out. When I factor a 2 out, I'm left with 8x cubed minus 1. So now we look at the binomial. First we see is our easy one. Is 8 a perfect square? No. 1 is a perfect square, but 8 is not, so I can't do that. But I also know that 8 is a perfect cube, and so is 1. So that's going to be our special case, the difference of cubes. Before you start the test, it would be a good idea, if you have this down, is to kind of write the formula down while it's still stuck in your brain. So it's a plus b, it's a squared, so it starts with a squared and ends with b squared. It's a perfect cube, so it kind of makes sense that you'd have to have 3 a's and 3 b's. One is plus, the other ones has to be minus, because for it to factor with no middle or to multiply out to no middle term, one had to be plus, the other had to be minus, and so you just have to remember that it's a times b. Okay, so what we have here, so the first thing I always do, take the cubed root, so that's going to be 2x, and that's going to be 1. So I just follow the formula, 2x, actually I'll do it once here, so 2x minus 1, it's going to be 2x squared, and then it's going to end with positive 1 squared, and it's going to be plus 2x times 1. And when I multiply all that out, it's going to be 4x squared plus 2x plus 1. And just don't forget the 2 that you originally factored out. And that's your final answer there. Okay. These are actually pretty simple. So, or actually, well, not number 9 is a little bit different, but 10, 11, and 12 are pretty easy. Not a lot to them. So factor the polynomial completely. So for this guy, I look, I have negative 20. I'm still focusing on that, 4 and 25. So I'm looking for two numbers. I have to multiply to be 4 times 25, which is 100, and have to add to be negative 20. So we have things like 10 times 10. Okay, well, and we know and that one actually works because they're both negatives. So it's going to be negative 10, and negative 10 is actually adds to negative 20. So I split the middle. So, and it always keeps the variables from the middle term. So this is negative 20xy. So this is going to be negative 10xy minus 10xy. And then we just carry down our first term, and we carry down our last term. Okay, so I look at this here and here. Again, we split it up into two parts. I know my greatest common factor with the first two is going to be they have a 2 and an x in common. I factor that out. I have one x left here. I have a 5. This x comes out here, so I'm left with y. I notice my third term is negative, so I'm going to carry down that negative. Greatest common factor here is, oh, you know what I dropped? I dropped a 2. Sorry about that. Greatest common factor here is negative 5. Negative 5 goes into negative 10 2 times. I also notice they have a y in common, so I need to factor out a y, 5y. So this is going to be 2x plus 5, and one of these y's is taken out, plus 5y. Actually, I did that wrong. It shouldn't be plus, it should be minus 5y, because negative 5y goes into negative 25 negative 5 times, so don't make that mistake. How did I realize I made that mistake? I see that this is minus, so the second term should also be minus. They should match each other. So I apologize for all the mistakes. 2x minus 5y, so that they have those in common, times 2x minus 5y. Okay, and you can have this, or you can have 2x minus 5y squared. All right, number 10, middle is already split for you. So all you have to do is separate this into two separate problems. So we have x squared and x minus 3, because I factor out an x squared from those two terms. These two terms, the next two terms, their greatest common factor is negative 5. So I factor out a negative 5. I'm just left with x here, and then negative 5 goes into positive 15. Negative 3, I know I did it right because I have the same term twice. So this is x minus 3 times x squared minus 5. So that was that one. 11. It's one of those ones you have to split the middle. Okay. So I know that it's going to be 18x squared. There's going to be two middle terms here, and then negative 2y squared. Okay, so I have to think about it. 18 times negative 2 is negative 36, and they have to be add to be negative 5. So they have to multiply to be a times c and add to be b. So I go through, think about the things that multiply to be 36. So we do have negative 18 and 2, but that would be negative 16. So that's not right. So then I think about what else. It's going to be negative, let's try, next one that comes to mind is negative 9 times 4. And sure enough, that does give us negative 5. So I know that's going to be positive 4xy, because remember it keeps the variables from the middle term, minus 9xy. For the first one, greatest common factor here, only thing that 18 and 4 have in common is 2. But their terms also have an x in common. I factor that out, that's going to be 9x plus 2 goes into 4 twice, y. For my third term, I have a negative, so I know I'm going to factor out a negative. The only thing that they have in common is actually a -1, and they also have a y in common. So -1 goes into -9, it's going to be +9. The y is factored out, so that's no longer there. -1 goes into -2, +2 times with a y. So 9x plus 2y, 2x minus 1y, or 2x minus y. Alright, number 3, last one. This is already 4 terms, so we've kind of had the middle split for us already. So I find the greatest common factor of the first 2 terms, which is just plain old x. They have nothing else in common, so this is going to be 3x squared. Negative, the x is factored out, so I'm left with a 5 and a y, so that x is factored out. This is plus, so I'm going to have a plus here. Greatest common factor of 6 and 10 is 2. They also have a y in common, so don't forget that y. And so I factor a 2 and a y out, that's left with a 3x squared minus 5y. I notice that I have the same thing, so I know that this is going to be 3x squared minus 5y times x plus 2y. So because that's what's left over, the x and the 2y, and that's your final answer. So not so bad. Hopefully factoring is getting a little bit better for you. So that's about it.